Okay, guys, I want to work some of these problems with you. Um, I'll leave it at that for right now. We'll chat a little bit later about the lack of effort on some of your parts to really try these. You just see them and got afraid, but that's for another time. Let's work some of these together. I'm looking at 32. And I'm supposed to find the area of the yellow piece, the yellow part. So in 32, I have a square. If I found the area of the square, and I removed from it the circle, then I would have the shaded region. So let's do that. The area of a square is a side squared, and the area of a circle is pi r squared, and that's going to equal to the area that we're looking for, and they tell us to round to the nearest 10. Okay, so with my square, I have 18 squared minus pi. Now, what's my radius of that circle? Well, if all the way across of it's 18, then half of it, or my radius, is going to be 9. So this is times 9 squared. So I'm going to have 18 squared minus 81 pi. So in my calculator, I'm just going to put 18 squared minus 81 pi. And that is approximately, and they say nearest 10th, 69.5. And it's square feet. Now look at that for a second and see if that makes sense. Isn't that reasonable? Isn't that reasonable to work the problem in that manner? You just got to apply, take some initiative and apply things that you know to this guy. I mean, it's a lot easier than you think it might be. Okay? All right, now let's look at 33. Trying to erase that. Here we go. Oh, goodness gracious. It is not going to want me to erase. There, that's better. Okay, 33. Okay, we've got a circle here, and if we remove the triangle, then we have the shaded region. So the circle is pi r squared, triangle is 1/2 the base times the height. All right, I really don't know what my radius is by looking, but it's going to be easy to figure out, because if you look at number 33, you'll see that you've got a right triangle, since you've got a inscribed angle in a semicircle. And my two angles, or my two side legs, are the same, so I have a 45, 45, 90 triangle. So I've got a 5 on root 2 and a 5 on root 2. So to find, when a 45, 45, 90, to find the hypotenuse, once you're given the leg, you just take that leg and multiply it by root 2. So that's going to give me 10 as my diameter, or my radius is 5. So I'm going to have 25 pi as the area of the circle, and I've got to remove from that my area of my triangle. Now I'm going to put in here, let's put it in red. I'm going to put the height in here, or the altitude that we have to use. We know the base is already this entire length of the triangle. So that's 10. Now to find the height, that little red piece I've put in there, I have put a perpendicular in. And this time I know my hypotenuse is 5 root 2. I also know that my diameter was 10, so this is 5. Okay? So my height is always my short leg times the square root of 3. Square root of 3. Now, let's see here. If I have I don't have a 30, 60, 90. I have a 45, 45, 90. My bad. Okay? So I still divide my, excuse me, my hypotenuse by root 2 to get my leg, and both my legs will be the same, so my height is going to be 5. So 25 pi minus 25. Let's put that in the calculator. 25 pi minus 25. We should get about 53.5. Again, it tells us to the nearest tenth. And this was square meters. Okay, so I'm going to give you a second to look at that. If you need to stop the video to look at that, do so. And we're going to move on to 34. See if I can make that disappear a little bit more quickly. Okay. Excuse me. All right, let's look at 34. And think through a reasonable way to solve this. I have a big circle. And I have taken out of that 2 congruent small circles. 2 times a small circle. And that gives me my shaded region. Alrighty, so my big circle is going to be pi r squared. Let's go ahead and just take care of it, and then we'll look at the little one. The radius of the big circle is going to be 7, because they give us the diameter is 14. So 49 pi is the area of the entire circle, but I've got to take away from it 2 of those small circles. So let's see what the small circle's radius is going to be. If the whole distance across here is 14, and then half of that distance is 7, then that means half of that distance is going to be 3.5. So the radius of the small circle is 3.5 squared. So as I put this, let's see what 3.5 squared is. So it's minus 2 times 12.25 pi. And if I double that, again, see how I'm using my calculator to help me with my work, but not to replace my work. It should be a subtraction. So now 49 pi minus 24.5 pi equals about, well, it equals 76.969. They tell us to round to the nearest tenth, so when I round this to the nearest tenth, it would become a 0 because it's 10, and that's going to really give me 77.0 to the nearest tenth square millimeters. Okay, does that make sense? Let's look at 35. We have a rectangle, and we're removing from it 2 congruent circles. So I've got a base times the height minus 2 pi r squares. Well, my base and my height, they're 10 times 5 minus 2 pi. Now I need the radius of one of my circles, and I can see that 5 is the diameter of a circle, so the radius is going to be 2.5. So I'm going to have 50 minus 2.5 squared is 6.25, and I need to multiply that by 2. So that's going to give me 12.5 pi. So let's see if we can drop that in. 50 minus 12.5 pi is about 10.7 to the nearest 10th again, and that's square centimeters. Okay? All right, let's look at 36. Pause the video if you need to study this one. "36 looks like I could take two approaches. I have two sectors that I'm looking for, so I get 2 times the area of my sectors. There's congruent sectors. Or I could take the circle and subtract the 2 white sectors, and what I'm left with will be the shaded region. I think the first way is much easier. So as I look at my drawing here, I know that my little red angles in there, they have to be 50 degrees because they form a linear pair with the 130. So we've got to remember our formula to find the area. Let's see if I can put it, I'll just put it over here. The area of a sector is A, which is my area, over pi r squared equals x, or my central angle, which in this case is going to be 50, over 360. So if I just take, let's reduce this, 5/36 and multiply that by pi r squared, which is pi, and my r is 9, so, my r is 3, so times 9. That should be my area. So 5/36 times 9 pi, we're going to put in our calculator. Okay, so I'm going to put this in my calculator. I put in 9 pi first, and then after I get that, I'm going to multiply that by 5, and then I'll divide by 36. And I'm getting 3.9 for one of them. Okay, so one of those sectors is 3.9 or 3.93. So when I double 3.93, 3.93 times 2 then, rounded to the nearest 10th, is going to be 7.9. And this is again in meters. These are not nearly as scary as they look, but they're important because you'll see them definitely on the ACT. They do a lot with these circles that have shaded regions. Okay, let's look at number 37. All right, this time we have three sectors we need to find. So we can either find the 3 sectors, or we could find the circle and subtract the white sectors, whichever that you makes sense to you. Notice that let's see, how can I, these white sectors, this is a 45, so this is going to be a 45, and that's going to be a 45. So I've got 360 degrees in the circle, and I'm taking away from that 3 45s. So that's going to leave us with 225 degrees that they tell us are evenly divided. Okay, so if I divide that by 3, each of my angles inside the yellow is 75 degrees. Okay, now let me clean that up a little bit because that's getting a little messy. So by reasoning, we know that I've got a 75 degree angle in there. So I have 3 sectors, so I'm going to have to find my sector. My area is the central angle over 360 times my area of the circle, pi r squared, and I'm going to have 3 of those. So 45 over 360, which I can reduce if I want to, and my radius is 2, so 2 squared, so we have times 4 pi, and then I'm going to triple that answer. So I'm back on my calculator now. Let's see, this is 45 over 360 is 1/8. So 1/8 times 4 pi is really 1/2 pi, or pi over 2. So I'm going to have 3 times pi divided by 2, and that's going to give us 4.7. Wait a minute, wrong one. Oh, I'm sorry, I put in the 75. I should have put 75 there. My bad. Let me clean that up a little bit for you. Last thing y'all need is for me to have it. Okay, so I've got the 3 sectors. I'm sorry. The 3 sectors. And the sectors are 75 over 360 times pi r squared. I'm sorry that I made a mess out of that. So now we're ready to put into our calculator. Let's see them. I'm going to write it like this so that if I talk it out, or as I talk it out, you may get a chance to just hear what I'm doing. I will do 75, and my way's not the only way. I'm just doing it my way. 75 times 4 times pi, and then I'm going to divide that by 360, and then I need to multiply that by 3 because I have 3 of those shaded regions, and I will get, when I round to the nearest tenth, 7.9. Again, 2 in a row we got 7.9. Okay, this was 37. So take a minute, look at that if you need to. Now, as you look at this second page, you have some more pretty little drawings. And what I want you to do, now that I've shown you how to do 32 through 37, use that same reasoning to do 40, 41, 42, and I believe it's 45 below. Okay, use the same reasoning that we did before and all the things we've had in the past. A lot of old information is going to be used on number 42 for sure. But use all of that information to try to come up with these others, okay? I'm not going to hand those to you right now. We'll talk about them if we need to in class. Okay? All right. We'll see y'all Thursday.